Today we're going to be talking about radicals, and we're going to be talking about rational exponents and roots. So our first little definition we have here talks about how you can go from a rational exponent into a root, or you can also read it backwards and go from a root to a rational exponent. So here it says a raised to the m over n equals, now here we have the nth root, and I'm saying nth root because n is the index number right there. And then inside the nth root, we have a to the power of m. So on a fractional exponent, the denominator becomes your index number, which is on the outside of the root, and your numerator stays as a power inside the root. So let's look at example number 1. It says convert it from exponential to a radical form, which just means have a root. Okay, so 3 is my base, that's the big number, and then my exponent is 1/2. I know it's typed a little weird, but that 1/2 is supposed to be an exponent. So when you make your root, okay, remember the denominator becomes the index number, so that goes on the outside of the root. The numerator stays inside with the base. So it should be the square root of 3 to the first power. Okay, the next one. Here's my base, which is x. Here's my root. The denominator is 3, so that goes on the outside. The numerator is 1, so it goes on the inside. So you're looking at the cube root of x to the first power. Now, example number 2, we're going backwards. This time I'm giving you the roots, and I want you to write it as a fraction exponent. So underneath the root, you have 7, so that's going to be my base. Okay, the 7 doesn't have an exponent, so that means it's to the first power. Whenever you see a root without an index number, that means it's a square root. And for square root, the index number is 2. They just don't write it because they expect you to know that it's 2 because we call it a square root. So remember, inside is the numerator, outside is the denominator. So it should be 7 raised to the 1/2 power. Okay, on B, let's start with the 10. Okay, the 10 doesn't have a power, so I put a little power of 1 there. So numerator on top. So the inside number becomes the numerator, and then the outside number becomes the denominator. So you should have 10 raised to the 1/4. Now let's look at x. X has a power of 3, so that becomes the numerator. And the denominator is the outside, which is 4. So then also we have x to the 3/4. Done. Now our next example for this one, we are going to simplify roots. Now in the past we have simplified square roots, but now you're going to notice that we have different index numbers. So on A, we have a cube root, which means our index number is a 3. So first, we're still going to do factor trees like we did with the square root. So find anything that goes into 135. Well, that would be 5 and 27. 5 doesn't break down, but 27 breaks down into 9 and 3. And 9 breaks down into 3 and 3. Okay, this time, since my index number is a 3, I'm looking for 3 of the same number. And hopefully everybody says, oh, look here, I have 3 3s. So it's not like a square root when you were looking for 2 of the same number. This time we got to look for 3 because it's a cube root. And then my leftover number is 5. So I'm going to put a 3 on the outside. Then I get cube root. So there's my cube root. And then my single goes on the inside. So my answer is 3 cube root of 5. On the next one. Okay, we've got letters involved this time. But let's just stick with the numbers first, the coefficient number. So let's break down 486. So I'm going to go 243 and 2. 243, I'm going to go with 81 and 3. 81, I'm going to do 9 and 9. 9s, I'm going to go down to 3s and 3s. So remember, what's my index number? My index number is 5. So what do I have 5 of? And hopefully everybody agrees I have 5 3s. So I get to put a 3 on the outside. And I'm going to leave some space because we're going to have some letters to deal with here in a minute. And then fifth root, my single number is 2. And that goes on the inside. So now let's talk about the letters. I have a to the 8th power. A to the 8th power, well, that means I have 8 A's. So 1, 2, 3, 4, 5, 6, 7, 8. So if I have 8 A's, how many groups of 5 can I get out of that? And everybody's going to be like, oh, look here. I can circle 5 of them. And that's the only 5 I can circle is just one set. So I get to put A to the first on the outside, or just A, because there's only one set. And then how many are left over? So how many could I not get in a group of 5? And hopefully everybody says, oh, well, that's 3 different A's. So that means inside I have A to the 3rd power. Okay, so hopefully everybody's getting the hang of it. For B, if you have 14 B's, how many groups of 5 can you get? And hopefully everybody says, oh, well, I can get 2 groups of 5 because 5 times 2 is 10. So on the outside, we have B to the 2nd. That means I've used 10 B's. So if I have used 10 B's, that means 4 are left over, because remember, I started with 14. So B, the 4th, goes on the inside. Okay, C's. I got 5 C's. Well, I need 5 C's to take 1 out. So that means I can only take out a C to the 1st power. And there are no C's left because I actually used all of the C's. So I am done. So let's just try it all over again. Factor tree. I'm going to do 324 and 4. Then I'm going to do 81 and 4. My 4s I'm going to break down to 2 and 2, 2 and 2. 81 is 9 and 9, 3 and 3, 3 and 3. So what's my index number? It is a 4. So look for groups of 4. And then you can say, oh, I got 4 2s. And I also have 4 3s. So on the outside, I get to put 3 times 2, which is 6. And then there are no single numbers. So I do not have a coefficient inside my 4th root. So for A, how many sets of 4 can I get out of 8? Hopefully everybody says, oh, well, I can get out 2 sets. So A squared. And I used all 8 of my A's. How many sets of 4 can I get out of 17 B's? Well, that will be 4, because 4 times 4 is 16. And if I've used 16, that means I have 1 B left over, and it goes on the inside. For C's, I got 12. Well, I can get 3 sets out of those. So then I'm going to have C to the 3rd. And that uses all 12 of my C's. D, I only have 3 D's. So I can't take any sets out because I have to have at least 4 to take 1 out. So no D's come out. So all D's stay on the inside. And then we're done. Okay. But then let's do roots again, but let's this time do some operations with them. So if you look at example 4 on A, we are going to be adding and subtracting with roots. Now, what you need to know is in order to add or subtract with roots, they have to be the same number underneath. So first off, square root can only be put with square root. Cube root can only be put with cube roots. And you can only add square roots together or subtract them together if they both have the same number underneath. So right now, my square root has a 20 and my other square root has a 5, and those are not the same number. But I should be thinking to myself, oh, can I do a factor tree and break some things down? So here, 20, I'm going to do 4 and 5, and 4 goes to 2 and 2. Remember, square root means the index number is 2. So what do I have a group of 2 of? And hopefully we all say 2's and a single 5. Now remember, I already have a 5 on the outside. So keep that 5 on the outside. So just bring that down. And then we're going to multiply that by 2 because of my group. And then inside, I'm going to have a single 5. So that becomes 10 square root of 5. And now you notice 10 square root of 5 and this minus square root of 5, they both now have the same number under the square root. So I can subtract them. And to subtract them, you're going to subtract their coefficients. So 10 minus 1 will give me 9 square root of 5. So now let's move on to the cube roots. So let's break down 16. I'm going to go 4 and 4, 2 and 2. And then remember cube root, so I'm looking for groups of 3. So I got 3 2's and a single 2. So right here I got that negative in front. So keep that negative. So negative. I got to put a 2 on the outside and then cube root of 2. 250, let's break that down. I'm going to do 10 and 25. 10, I'm going to do 2 and 5. And 25, I'm going to do 5 and 5. So remember, cube root, so looking for groups of 3. Boom, got 3 5's and a single 2. Now don't forget you got this 6 out in front, so keep that 6 there. So I'm going to take 6 times 5, and that's going to be 30 on the outside. And then cube root of my single number, which is 2. And now when I look at my cube roots, you're going to say, oh, both cube roots have a 2 underneath them, so I can combine my outside numbers. So negative 2 plus 30 is positive 28 cube root of 2. And then hopefully everybody notices when you're adding and subtracting them, we're not changing the number under the root. We're only changing the outside number. Now, the next operation we can do with roots instead of adding and subtracting is multiplying. So now we're going to multiply, and if I have 2 items times 2 items, everybody should be thinking box or foil. So I'm going to make my little box here. So I got square root of 3, 5, square root of 2, square root of 6. Now remember, you can multiply anything together you want. So square root of 2 times square root of 3, I can keep my square root and then multiply the numbers underneath, and 2 times 3 is 6. So that becomes square root of 6. Now when I take square root of 2 times 5, okay, I can't take 5 times 2 because you're going to notice the 2 is under the square root and the 5 is not. So all I can do is just push those together and make it 5 square root of 2. Now square root of 6 times square root of 3, hey, those are both under square root, so I can actually multiply those numbers together, and that will make it square root of 18. 5 times the square root of 6, that can't actually multiply those together because they're not both underneath the square root. So I'm just going to write them next to each other. Hey, look here. I noticed that I have a square root of 6 and a 5 square root of 6. Well, let's combine those because they both have a square root of 6. On the first one, if there's no number out in front, is everybody okay? That is a 1 square root of 6. So 1 square root of 6 plus 5 square root of 6 is going to give me 6 square root of 6. Now, I got a 5 square root of 2, which 2 doesn't break down with a factor tree, so I can't do anything with that. But then I got a square root of 18, and hopefully everybody says, ooh, I can break down 18 with a factor tree. So 9 and 2, 3 and 3. Remember, this is a square root, so I'm looking for pairs. So I got a pair of 3s and a single 2. So everybody needs to realize that square root of 18 is the same thing as 3 square root of 2. And now we can say, oh, well, 3 square root of 2, I can add that to 5 square root of 2 because they both have square root of 2. So add my outside numbers and I get 8 square root of 2. And here's my final answer. So now the last operation I can do with roots is division. So we got this whole last one, and with division, instead of saying divide them, we call it rationalizing the denominator. So what you need to know is you are not allowed to have a square root in the denominator. That's not considered proper math. Okay, so if I look at my first problem, I have 12 over the square root of 3. Well, I don't want that square root on the bottom. So what I'm going to do is I'm going to multiply the bottom of the fraction by that exact same thing, square root of 3. And if I multiply the bottom, I have to multiply the top as well to keep everything balanced. 12 times the square root of 3. I can't physically multiply those together because one's under and one's not. So I'll just write them next to each other. On the bottom, square root of 3 times square root of 3. I can multiply those together because they're both under. So 3 times 3 is square root of 9. And then everybody should be thinking, well, hey, wait a minute. I know something about square root of 9. I know the square root of 9 is really 3. So on the bottom, my square root went away completely. Now, before I circle and say the final answer, I want to make sure everybody makes this connection. If I take a square root times itself, so square root of 3 times square root of 3, the square root will cancel out and it will just give me the number 3. So if I said, what is the square root of 7 times the square root of 7? Everybody should just say 7. All right, the last thing you want to do here is always make sure we try to reduce fractions. And when I reduce fractions, I don't reduce the number under the root. I only reduce the numbers out in front of the root. So 12 and 3 are both divisible by 3. So then my answer becomes 4 square root of 3. Done. Now they're going to get a little harder as we go through this row, a little more complicated. Now on B, you're going to notice I don't just have one thing in my denominator. I have 2 items, and all the rest of them, C and D, they're in the same pattern. I got 2 items in the bottom. So I don't know if you remember this when we did this with i's, imaginary numbers, and we said you weren't allowed to have an I on the bottom. And we said to get rid of the I, you multiplied by the denominator, but you changed the middle sign. Hey, it works the same way with square roots. I am going to multiply the top and the bottom by the denominator, except for I'm going to change the middle sign. So I am going to multiply by 3 plus the square root of 5. So here I'm going to distribute my 7. So 7 times 3 is 21. 7 times the square root of 5 is 7 square root of 5. Now on the bottom, 2 items times 2 items. Well, I'm going to make a box. Okay, so here's my box. I'm going to put it way down here at the bottom. 3 negative square root of 5, 3 positive square root of 5. Okay, 3 times 3 is 9. 3 times negative square root of 5 is negative 3 square root of 5. 3 times square root of 5 is positive 3 square root of 5. And negative square root of 5 times positive square root of 5 is going to be, of course, negative times positive is negative. And then, hey, we just said if I'm multiplying two roots together and they have the same number underneath, they just cancel and give me that number, which is 5. So it should be negative 5. And then when you look at your box, hey, look here at my like terms. They both have square root of 5s in them, but a positive 3 square root of 5 and a negative 3 square root of 5, they cancel out. So there's no square roots. So it's just 9 minus 5. And 9 minus 5 is 4. Now, I can make this a little bit shorter for you, okay? Instead of having to do the box, you should know right now that your terms are going to cancel out, the middle ones. So what I would do is I would do first times first. So 3 times 3 is how I get 9. And then I would do last times last, and that's how I get this minus 5. We don't have to worry about the middle parts because we'll know they cancel out. But before I call this done, can I reduce? Well, 21, 7, and 4. Nothing goes into all of those. So my final answer is 21 plus 7 square root of 5 over 4. Done. Okay, same process. Let's just do it over. Multiply the top and the bottom by 2 minus the square root of 3. 2 minus the square root of 3. Okay, distributive property. 1 item times 2 items is distributive property. 5 square root of 3 times 2. We'll take 5 times 2, and that makes it 10 square root of 3. 5 square root of 3 times negative square root of 3. Well, that will give me negative 5. Square root of 3 times square root of 3 is really going to be the square root of 9, and the square root of 9 is 3. So essentially, you're looking at negative 5 times 3, which really makes that negative 15. So that was kind of tricky on the top. Bottom, let's do the shortcut because we know the middle terms are going to cancel out. So first times first. 2 times 2 is 4. Last times last. Square root of 3 times negative square root of 3. Well, negative wins. And then they're the same, so that'd be square root of 9. Square root of 9 is 3. So you're really looking at 4 minus 3, which is 1. We don't have to put anything over 1 because that doesn't matter if that's my denominator. So I am finished. One more. Okay, multiply the top and the bottom by square root of 5 plus square root of 3. Square root of 5 plus square root of 3. 2 items on top times 2 items on top means you got to box or FOIL that out. Okay, so down here at the bottom, I'm going to make a little box for this. So square root of 5, square root of 3, square root of 5, square root of 3. Square root of 5 times square root of 5 is square root of 25, which is 5. Square root of 5 times square root of 3 is square root of 15. 5 times 3 is 15. Square root of 3 times square root of 5 is another square root of 15. And square root of 3 times square root of 3 is square root of 9, which is just 3. So like terms, 5 plus 3 is 8. Square root of 15 plus square root of 15, well, that would be 1 square root of 15 plus 1 square root of 15 would make 2 square root of 15. Now on the bottom, first times first. Square root of 5 times square root of 5 is square root of 25, which is just 5. Negative square root of 3 times positive square root of 3, well, negative wins. Square root of 3 times square root of 3 is square root of 9, and square root of 9 is 3. So you're looking at 8 plus 2 squared of 15 all over 2. Oh, can we reduce? Well, 8, 2, and 2 are all divisible by 2. So yes, we can reduce. So my final answer would be 4 plus 1 squared of 15, or just square root of 15. Done.